Okay, so very good evening, everyone. Thank you for joining me live today on Python Chit Chat series, episode 1, Generators in Python. So, from today on alternate days, I'm coming live to discuss about various concepts in Python programming language, which were very important in terms of developing some projects on Python. And hope this series will help you and enhance knowledge on Python programming language. And hope you all will like the series and you will learn something out of it. So before we start, if you like this topic, you can hit like and subscribe our YouTube channel, and hope I'm on live. Hope my voice is also audible. So let's get started without any delay. And before we proceed further, let me introduce myself. A little intro about me. This is my LinkedIn profile. You can scan this QR code. It will take you to my LinkedIn profile and you can stay connected with me on LinkedIn. If you have any question or if you are developing any kind of project, so you can also get my suggestions or feedback in terms of developing your project. You can quickly send your message so I can help you out in doing that. My name is Madhu Parvatneni. I'm an IoT blockchain machine learning domain expert. So I'm working as solutions architect at Madblocks Technologies Private Limited, which is based out of Hyderabad. And today we are going to discuss about generators in Python. So I'll explain each and every concept in detail so that you can able to understand it with examples so that you can use this concepts in writing your programs for projects. Okay. And if you have any questions to ask, say if you are writing this program on your laptop or your desktop machine, if you get any problem or error, you can share that message in the Telegram group. So we have a common Telegram group and you can share your details or you can share your messages or you can share your error screenshots, and also you can get live updates from our channel. On this Telegram group you can quickly scan this QR code. It will take you to my Telegram group and you can quickly join in that and you can get live updates also. So you can get live updates, you can push your error messages, so whatever. Okay, you can do that in this Telegram group. Okay, so this is just a brief intro what we are and how we can help you out. And talking about this particular webinar, today we are going to talk about generators in Python. As this is our first episode in Python Chit Chat series, so we wanted to start with a simple one, which is like generators in Python. So the main objective of this webcast episode 1 is to tell you, what is generator, why it is very important, and what kind of concepts are there in generators, and how we could use generators in Python projects. So all that I can able to explain in this episode. So please stay tuned and watch this video and until I wind up. Okay, so that you can get you can get more important tricks and important stuff on generators in Python. If you want to become a paid subscriber, say if you want to get a certificate, so there is a registration link in this video description. You can register there. You can also get a certificate for this webinar. Okay, so without any delay, let us understand what is generator in Python. But before that, let us talk about the prerequisites. So prerequisites is nothing but if you want to start developing this, you should able to understand the basic concepts of Python. Okay, so I'm assuming that you people have a basic knowledge on Python programming. So yeah, you can able to understand the concepts of generators in Python. Before you learn anything, you should able to understand what it was and why it is needed, so that if you able to understand what and why, you can easily understand where you can use this. Okay, so let us understand what is generator, what is Python generator. So Python generators are nothing but functions that return a traversal object and which is used to create iterators. So what do you mean by this? This is generator is nothing but a function which looks like a normal Python function, but you will able to see a keyword called yield in the place of return variable. Okay, so generally functions will have return variables, right? So in the place of return variable, if you see a keyword called yield, then obviously that function is called as generator function. So let me take a small example here. If you see a function called Maddy and this function is having a keyword called yield, then immediately this is nothing but a generator function. So you can easily differentiate a normal function with a generator function. A normal function will have a return variable, or sometimes it doesn't have any return variable. If it doesn't have any return variable, it will return none, but by default every function should have a return variable. If you are not returning anything, it will return none, but if you are returning some data, so it is based on the data type and based on the project context, so you will be using return keyword there. In the place of return, if you see this keyword called yield, then obviously that is called as generator function. Okay, so let me walk through in detail so that you can you can understand much better out of it. Okay, so let me jump into the second slide so that I have given you a brief difference between a normal function and a Python generator function. So here there are two codes. Okay, here there are two codes. So there are two snippets here, one a normal function and second generator function. So let us go through these functions. Okay, so here let us look at the first one. Okay, let us look at the first one. So in the first one, if you see, you have a normal function. Okay, so you have a function called Maddy. So Maddy is nothing but function name, isn't it? So we have a function called Maddy. So Maddy is nothing but a function name which is not taking any arguments, and the value of a is 1. Okay, and the value of a is 1. So the value of a is 1, and if a double equal to 1, if the value of a is double equal to 1, so here a value is 1, 1 double equal to 1 is true, then immediately what we have written there, so we have written print a is 1 and written the value of a. So what it is doing there, it is doing a task like printing the value, printing the statement called a is 1, and it is returning the value to the function call. So then what will happen? So here in this program, so we have a value is 1 and we are comparing whether a value is 1 or not. So here as the value of a is 1, it will print a statement called a is 1, return a, and we have one more block here, a equal to 2, and the value of a is updated to 2, and if a double equal to 2, this is also true. Okay, this is also true, print of a is 2, return a. Okay, so we have two blocks. So we have two blocks in this function. So one block where the value of a is 1, we have a second block where a value is 2. So we have two different blocks here. So in the first block we have a value is 1, in the second block we have a value is 2, and in two different blocks there are two different return variables. In the first block you have written a, in the second block also you have written a, but we have different values for a. Okay, so we have first block here and we have second block here, and you can able to understand that Python executes line by line. Okay, so whenever you call this statement, okay, so whenever you call this statement, what will happen? Print of Maddy. So this is nothing but function call, right? So this is nothing but function call. Okay, this is nothing but function call. So what will happen when you call this function? So then immediately it goes to function definition, right? It goes to a function definition. Now what will happen? It goes to it goes to here, right? So it goes to a function definition. So whenever you call a function, it goes to function definition. In the function definition, we have a block here. So when here a value is 1, right? And if a double equal to 1, obviously true. Okay. Print of a is 1. So print of a is 1 is nothing but a is 1 will be printed on the console, and return a. Then what will happen? A value will be written. So what value it will return? It will return a value called 1. So which means that you will have something like a is 1 and the value 1 will be printed. Okay. So let us do this. Okay. So let us do this on Python interpreter. So I have shared a Google Colab link in this video description. You can quickly open that. I will also open the same notebook on my machine. So this notebook link is shared in the video description. You can click on that link. Okay, so here I'll just click on connect. Okay, Google Colab is a collaborative Python notebook which is hosted on Google Compute Engine. So when you have a Gmail ID, you can quickly access this. Okay, so your Colab notebooks will be shared in the Google Drive. So this is used to run Python scripts online. Okay. Okay, so here we have to click on connect. So whenever you click on connect, it will be connected with Google Compute Engine. So here we were talking about Python generators. Okay, so we are talking about Python generators. Okay, so here let me define the same function. Okay, def Maddy. So this is a function name, and we have two blocks here. A value is 1. Okay, if a double equal to 1. So here the value of a is 1. So 1 double equal to 1 is true. Then immediately it will enter into the if block. And inside if block, what I'll do, I'll write print a is 1. And also I'll call return a. Okay, I'm returning from the function. Okay. And in the similar way, I have another block called a equal to 2. And I'll have if a double equal to 2. Print of a is 2. Print of a is 2, return a. So here also we have we have the way a value is 2, and this is also true. Okay, this is also true. This is the second block which we have written. So this is a simple function definition. Okay, so this is nothing but simple function definition. Okay, so you can call it as called function also. Okay, a function definition or called function, whatever it is. And this function definition, we have two blocks. One is a equal to 1 and the second block is a equal to 2. And let me run this. Okay, so you have to hit this play button. So immediately this will be executed. So here if you see, we have defined the function. So you cannot able to see the output because we have defined a function now. That's it. Now here what we have to do, we have to call that function. Okay, so we have to call the function. So how to call the function? Say we have Maddy, right? That is a function name, and this is a function call, isn't it? So this is a function call, but this fellow is returning some data, right? So this fellow is returning some data. Let us have a return variable also, something like out equal to Maddy. So out is nothing but output. Okay, so print of out. So I wanted to print what it is returning. Okay, so out equal to Maddy, print of out. Then what will happen? So Maddy is nothing but function call here. So what is this Maddy, bracket open close? This is called as function call. So what will happen? So whenever this function is called, okay, whenever this function is called, immediately it goes to function definition. In the function definition, we have a value is 1, a value is 1, and 1 double equal to 1 is true. Then immediately what it will print? It will print a is 1. Okay, and it will return a. So what is the value of a now? If the value of a is 1, then immediately 1 will be returned to the place from where it is called. So thereby the 1 value will be stored in a variable called out. Okay, 1 value will be stored in a variable called out. Print of out. Print of out is nothing but immediately 1 will be printed. So let us look at the output. Out. So when you run this, you can able to see a is 1, and the value of a is also 1. So it is returning to a variable called out, and we are printing the value of out. Thereby you can able to see 1. Okay, so what happened here? So the most important point about return. Okay, so return always terminate the function. okay, though the next block is available, okay, though the next block of statements is available, but it will always terminate the function whenever it is called. Okay, so whenever Python interpreter encounters a written keyboard, so whenever a Python interpreter encounters a written keyboard, immediately the Python interpreter terminate the function. Okay, it will come out of the function. So when it is coming out of the function, it will not execute the next block of statements. So this block of statements will not be executed, because Python interpreter is coming out of the function. Okay, so the Python interpreter is coming out of the function, so thereby, so this block of statements which is highlighted will never execute, okay, which will not be executed there. Okay, so this is a normal Python function. Say I wanted to execute the first block and the second block also. Say I wanted to execute first block and second block also. Okay, then we should able to understand the concept of Python generator. Okay, if you want to execute block 1, so what is block 1 here? So this is the block 1, a equal to 1. Okay, a equal to 1, and the next if statement is block 1. Okay, a equal to 1, and the next if statement is block 1, a equal to 2, and the next if statement is block 2. Okay, assume that this is block 2, and a equal to 1, assume that this is block 1. Okay, so we have two blocks here. So whenever you write this kind of program, okay, whenever you use a keyword called return, so whenever the block 1 is executed immediately, so it will return the value of a, it will come out of the function. Okay, so we wanted to execute both block 1 and block 2. If you want to execute both block 1 and block 2, so we have to use a concept called generator function. Okay, so now let me write a generator function. Okay, let me write a generator function. So def Maddy, okay, same, I'll write Maddy underscore generator, or I can use the same keyword also, that is fine. Okay, a value is 1, if a double equal to 1, so the value of a is 1 double equal to 1 is true, it will enter into if condition block. In the if condition block, what I'll do is I will just print a is 1, I'll just print a is 1, and here I will have a keyword called yield. Okay, instead of return I will use a keyword called yield. Okay, in the place of return I will have a keyword called yield. So whenever Python interpreter encounters this keyword yield, what it will do is it will understand that this function is a generator function. Okay, is a generator function. So let me also define block 2. Okay, and then I'll explain what will happen here. Okay, if a double equal to 2, print a is 2 and yield a. Okay, if a double equal to 2, print a is 2, yield a. Now let me explain what will happen here. Okay, so we have block 1, so we have block 1 and we have block 2. So let me call this function. Okay, so say you are calling this function called Maddy. Okay, then what will happen? It will come to here, it will come to block 1, a equal to 1, so a value is 1, if 1 double equal to 1, obviously it is true, print a is 1, so a is 1, yield a. Then immediately what happens is your program, your function execution will be paused. Okay, whenever it encounters a keyword called yield, whenever it encounters a keyword called yield, immediately function execution will be paused. Okay, and it will send an instruction to the function call. Okay, so the function call can only resume the process. Okay, the function call can only resume the process. Okay, can only resume the process. For example, say let me run this program. Okay, let me run the snippet. Let me call the function. Okay, so here if you call something like this, okay, say print of, sorry, we'll do like this, k equal to Maddy. Okay, print of k. Okay, k equal to Maddy, print of k. So Maddy is nothing but function call. But what is this function now? this function is nothing but generator function, because we have yield keyword inside. Okay, instead of return we have yield, so this is nothing but generator function. Okay, so we have a return variable called k. So let me run this, you will understand easily. So what it is saying, it is saying that this is not a normal function, this is a generator object. So which means that it has returned, an iterator object. So it has written an iterator object where you need to iterate. Okay, where you need to use some keywords here. Okay, so where we have to use something like this. Okay, if you want to if you want to get the block 1 output, so you have to use a method called next. Okay, so for example, say next of k. Okay, next of k. So when you call next of k, okay, when you call next of k, immediately you can able to see the first output. Okay, first block output. So next of k is nothing but which executes till the function call is paused. Okay, so this is nothing but block 1 output. If you want to get block 2 output, again you have to call next of k. So next of k is nothing but the name itself says it has to call the next thing. Okay, it has to call the next yield part. So we have block 2 here, right? So after completing this, okay, after completing this, what will happen? There is one more block here, right? So after this there is one more block here. So here also a equal to 2, a double equal to 2, 2 double equal to 2 is true. Immediately print of a is 2 will be printed, but we have a statement called yield a. Now the function execution will be paused, and the the controller will go to function call. So in the function call you have to write something like next of k, then immediately the next block will be executed. So you can able to see the next block output here, a is 2, but when you use a simple return keyword, block 2 will never be executed. But whenever you use a generator object, something like yield, so whenever you use a keyword called yield, then obviously you can able to understand that your the function call, the function definition execution, so the execution of this function will be passed, and the generator object has to be called by using next method. Okay, then immediately that block output will be achieved. Okay, and if you want to get the next block, then immediately you have to call next of k again. Okay, what is k here? K is nothing but the generator object. If you call next of k again, okay, as we have only 2 yield, you can call only next to 2 times. Okay, if you have 3 yields, then you have to call next 3 times. Say if you call next of k again, then you will get an exception. Okay, you will get an error saying that the iteration was stopped because there is nothing to iterate again. Okay, so there is nothing to iterate again. So if you see, yield keyword was written 2 times. Okay, yield keyword was written 2 times, and thereby you can able to see only 2 times it will execute, and third time if you call, you will get something like stop iteration. So stop iteration is an exception where it will be raised automatically if nothing to iterate. Okay, if there is nothing to iterate, obviously you will get this exception. Hope you understood. Okay, hope you have understood. So let me recap again. So whenever you have written keyword, okay, so whenever you have a written keyword, the function will be terminated there itself. It cannot execute block 2. Okay, so in some project cases you have to execute both block 1 and block 2. Then you have to convert this function as a generator function. Then in the place of return you can put yield. So when you put yield, so that will become the return variable will become as a generator object, and you can call next method to execute that block 1 and block 2, so that you can able to get the output of both blocks. Okay, so let me take one more example. Okay, so this is one case where you will be using generator functions. Okay, so let me take one more example here. Say we have a function. Okay, so when you define a function, we cannot say is this a normal function, generator function. Okay, when you see a keyword called yield, then only you can understand that this is a generator function. Okay, so str1 equal to Maddy. Okay, yield str1, str2 equal to hello, yield str2. Okay, so here we have two yields. Okay, so we have str1 equal to Maddy and we have str2 equal to hello. Okay, now whenever you see a keyword called yield, it is nothing but generator function. Okay, let me call this function. Okay, let me define it. Let me call this. So if I call something like this, okay, so you should have a return variable. Okay, something like out equal to Maddy. Okay, out equal to Maddy. If you want to get string 1 first, okay, if you want to get string 1 first, you have to call next method. Okay, then only it will be executed. So next of out. Okay, next of out, then what will happen? You will get the first string output, which is nothing but Maddy. Okay, next when you call next method again, next of out, then immediately it will be calling the second yield, which is nothing but we have a message called hello, so that will be printed. If you call it for the third time, you will get stop iteration error. Okay, you will get stop iteration error, you cannot proceed further because we have only two yields here. Okay, so you can have something like this, or you can also use for loop to iterate the generator object. Okay, for example, say we have a equal to say def Maddy. Okay, a equal to 1 2 3 4 5. Okay, a equal to 1 2 3 4 5. Now what I wanted to do is I wanted to do something like this. Okay, for I in a, yield I. Okay, yield I. So let me call this. Okay, now here generally what we can do, we can create a generator object, right? Out equal to Maddy. So we can create a generator object and we can keep calling next keywords. Okay, so for example, say when you call next of out, then immediately you will get the first value, right? You will get the first value, which is nothing but 1, because this is a list. Okay, so this is a list of values. When you call next of out, you will get 1. Why? So in this function, if you see, we have a equal to 1 2 3 4 5, and for I in a, so what do you mean by I in a? I is a iterative variable, and what will happen, it keeps pointing to all the elements in the list. So in the first iteration I value is 1. So what will happen, now in the first iteration I value will be 1, then immediately yield I. So here the function execution will be stopped, will be paused, right? So here the function execution will be paused when yield is encountered. Okay, so here we will be having something like yield 1. So yield 1. So that is why when you call next next of method, so you will get able to 1 as an output. And if you call this again, okay, if you call this again, so as the for loop is there, so it I and points to 2, thereby I value will become 2 and the function will be paused and you will have yield value as 2. Then whenever you call this, you will get something like 2, and if you call it again next of out, so you'll get yield value as 3, so that in it yields at 3, so the output will become 3. So like this, if you call next of out again, you'll get 4. If you call next of out again, you'll get 5. So instead of calling this many number of times, okay, so instead of calling this many number of times, what we can do is we can also iterate the generator object. Say for example, for j in out, okay, print of j. So here out is nothing but generator object. Okay, out is nothing but generator object. Out is nothing but generator object. So what I'm doing, I'm just traversing through this generator object by using a for loop. Then immediately you can able to see one. Already 3 was iterated out. So then you can able to see 4 and 5. For example, say if I call this function, if you call this program snippet again, out equal to Maddy. Okay. So now what I'll do, I'll simply call this. Okay, whenever I call this, you can able to see all the values getting printed one by one. Instead of calling next 5 times, you can use a simple for loop and you can traverse through the generator object and you can able to achieve all the values at one step. Okay, instead of calling next of out 5 times, you can have this kind of task, right? Out is nothing but the generator object. This is a return variable from the function, right? So what it will return when you have yield keyword? When you have a yield keyword, it will always return a generator object. Okay. So whenever you have a yield keyword, it will always return a generator object, and thereby to get one by one, you have to call next method. Otherwise, if you want to get one by one very fastly, you can iterate this generator object by using a simple for loop. Okay. So let me go back to the function. Okay. So here, if let me go back to the PPT. So here in this second program, if you see, okay, the second program, if you see, in the second program we have a function. Okay, we have a function a value is 1. So this is already we have written this code, right? And here we have yield. So whenever you have yield, then obviously this is a generator function. So what it will return? It will return a generator like object, right? So it will return a generator like object. Okay, and you have to traverse through the generator like object either by using next method, or you can use a simple for loop as we have discussed. So you can traverse through the generator object. Okay. And why we need these generators in Python? That is what we have to understand. Generators always provide a space efficient method for large data processing. For small data processing, I don't see generator will create a much efficient factor. But for large data processing, say if you want to print 150 numbers, okay, if you want to if you want to create a data pipeline for about 150 numbers, so generally you have to iterate, you have to take a list, and you have to allocate memory for all 150 members. But here you can use generator object, and that generator object will be allocating memory for only one member, so that all the 150 members can share that memory, and they can you can able to complete your task. So this is like an union. So generally in C programming language, you'll have a union, right? Union is nothing but your memory will be shared between the members. So here also, for one member it will allocate memory, and that member memory can be processed in between all the generator object values and all that. Okay, so that is a main important advantage of Python generators. Okay, so that is why people use Python generators in real-time scenarios also in various aspects. So let us look at the main advantages also, which is like why it is more important in the later coming slides. Okay, so I guess we have taken this example in the Google Colab. So we have a function called Maddy, and what we are doing, we are assigning Maddy to A. Okay, we are assigning Maddy to A, yield of A, then immediately the function execution will be paused, and it goes back to the it goes back to the next of K. So immediately you can able to see Maddy as an output. Okay, and next we have next of K again, so B equal to YouTube, and yield of B, so that you can able to see YouTube as an output. Okay, hope you have understood this example, because we have taken the similar example in the Google Colab to talk about Python generators. So here, let us look at Python generators with loops. Okay, I have also taken a different example, but this example also you can try it out. Okay, say for example, people ask you to write a program to print even numbers from 1 to 10 by using Python generators. Okay, so they have asked you to write a program to print even numbers from 1 to 10 in the range of 1 to 10. Okay, in the range of 1 to 10, and using generator function. Okay, so let me define a function called even. Okay, let me define a function called even. So here let me take a simple for loop. Okay, for I in range of 1 comma 10. Okay, 1 comma 11, because generally when you take 1 to 10, 10 is not 1 comma 10, 10 is not inclusive. So I'll take 1 comma 11, because 1 to 10, 10 will be inclusive. Okay, it depends on the condition. For I in range of 1 comma 11, and if I percentile to double equal to 0, okay, if I value is is divided by 2. If the remainder is 0, then it is obviously even number, right? So here what I'll do is I'll just yield the value of I. Okay, I will not return the value of I. What will happen if you return I value here? It will come out of the function, right? When you write, for example, say return of I, let me explain this. Okay, return of I, and now if you call the function, okay, if you call the function, what will happen? It will print only the first even number in between 1 to 11, right? It will print only the first even number, because 1 is not even, right? So what is the range of 1 comma 11? A range of 1 comma 11 is nothing but it starts from 1 2 3 so on, 1 2 3 so on 10, right? So what is the first even number here? 2 is the first even number. So because 1 is not even number, so 1 percentile 2 is not 0. It will go to the second element. Second element is nothing but 2. 2 percentile 2 double equal to 0 is true. Return 2. So 2 will be printed, and it will not it will not go for 3, it will not check for 4, it will not check for 5, and so on, because return is nothing but which breaks the function execution, okay, which terminates the function execution. Okay, so that is why in this case we cannot use a keyword called return. Okay, instead of that, I will be using a keyword called yield. So whenever you use a keyword called yield, then what will happen? It will return a generator like object. You cannot able to see all even numbers here. You'll get a generator object, and this generator object you can traverse, right? You can traverse like an iterator. Okay, so even now if you call even, now you'll get generator object because we have a keyword called yield. So now what we can do, we can use next method, or you can traverse by using for loop also. Okay, for example, say if you want to call next method, okay, say next of even, say we have some written variable, okay, k equal to next, k equal to even, okay, k equal to even, and k is generator object. So let us have something like next of k, okay, next of k. So you will get 2. So what is the next even number after 2? It is nothing but 4, right? So when you call next of k again, you will get something like 4, because 4 is the next even number. And when you call next method again, you will get 6. When you call next method again, you will get 8. If you call next method again, you will get 10. Okay, like this, using next method you can iterate. But sometimes it will be difficult to call next method again and again, right? So that is why we will be using a for loop to traverse through the generator object. Okay, so let me use a simple for loop instead of using next keyword every time. Okay, I can have this statement k equal to even, and for I in k, okay, print of I. So what is k here? K is nothing but generator object. K is nothing but generator object. So here k is nothing but generator object. What I'm doing, I'm just traversing through the generator object by using a simple for loop. You can able to get all outputs at instant, 2 4 6 8 10. Okay, so this is nothing but traversing through the generator object. Okay, traversing through the generator object without using any method called next. You can use next method, or you can use traversing through the generator object by using loop. So that is also fine. Or you can use next method, but always we cannot depend on next method, because if your program is, say if it is returning almost 100 150 values, you cannot have next every time, right? So you can use a simple for loop. Okay, so this is also fine. Or you can use something like this. Okay, that I will explain to the PPT. Okay, so you can able to see all this, right? This is done. Example 3. So this is a Python generator expressions. Okay, so this is Python generator expression. So let us do this. Okay, so let me take a variable a equal to, okay, x to the power of 3 for x in, okay, so let me take some list. Okay, l equal to 1 2 3, okay, 1 2 3 for x in range of l, okay, For example, say a equal to x to the power of 3, double star. Double star is nothing but exponent, which is nothing but x cube. So this is called generator expression. Okay, so this is called generator expression. Okay, generator expression for a equal to bracket x to the power of 3, which is nothing but x cube, for x in range of L. What is L? For x in L, sorry, for x in L, because we have taken L is nothing but list, right? For x in L, so x in L is nothing but L is nothing but 1 2 3. So x points to 1. What is 1 cube? It is 1. And what is 2 cube? It is 8. What is 3 cube? It is nothing but 27, right? Let me print the value of a for you to understand. So what you will get generator object, because this is a generator expression. What you can do, you can use a simple next method, or you can use, for example, say let me use next method. Okay, so you can call next of a, you'll get 1 as an output, because 1 cube is 1. If you call next of a again, 2 cube is nothing but 8. Okay, so when you call next of a again, okay, you'll get 3 cube, which is nothing but 27. But there is no next element to iterate, right? So next of a, you'll get stop iteration exception. Okay, you'll get next of a is nothing but, because after 3 there is no next element, so you'll get stop iteration error. Okay, so like this you can have a generator expressions also. So there is I'll show you a difference now. List, because sometimes people talk about list comprehensions, right? Say for example, x value, say L value is 1 2 3. Okay, so we have something like a equal to same example I'll take, x to the power of 3 for x in range of, sorry, for x in L. Okay, this is one kind of thing. And b equal to square bracket x to the power of 3 for x in L. Okay, so there are two variables here, one is a and one is b. So let me print both a followed by b. Okay, so one is generator expression, second one is list comprehension. So if you see here, a equal to bracket open, x to cube for x in L, and the second one x cube for x in L, which is nothing but square bracket. When you see a square bracket, this is called list comprehensions. Okay, and when you see a small parenthesis, this is nothing but generator expressions. Okay, generator expressions. Now let me take a small example. Okay, now here if you want to get this values for a, you can use either a next method, or you can go for what? You can go for I in a, you can go for loop, you can traverse through it, print of I. So immediately what you can get, you can able to see 1 8 27. Okay, you can use a simple for loop to iterate through the, what is a is nothing but generator object. So the generator object you have to traverse. Okay, so you cannot get the outputs directly. That was a generator object that holds iterative values. Okay, you have to call either next method, or you can call this simple for loop syntax. Okay, so when you put square bracket, it is called list comprehension, and when you put bracket open and close, that is nothing but generator expression. So don't get confused in between generator expression and list comprehension. Generator expression will have a small parenthesis open and close, and list comprehensions will have square bracket open and close. Okay, so generator expressions will return generator object, it will not return values directly. Okay, it will return a generator object instead of returning values. So when you have a generator object, what you have to do, you have to call either next keyword, or you have to call either through for loop. Okay, what are the advantages of generator? So it is easy to implement, right? So we can use a simple for loop or next method to implement the concept of generator, right? And you can use simple yield, and thereby we can able to yield the process, right? So it was very easy to implement. And talking about memory, it was very efficient. Okay, it was very efficient. Let me take one more example. So let me take an example. What is this? Yeah. So here we have taken this example, right? So let me take same example to show you how much memory it has been allocating for. We are talking about memory efficient, right? So import sys. Okay. So let me paste that print of a and b. So here one is generator expression, second one is list comprehension. Okay. So let me okay. So let me print how much memory is taken for A, how much memory is taken for B. Okay, so print of sys dot, so it is giving some recommendations also. Let me have, yeah, get size of, okay, get size of object. What is the object? A, isn't it? In the similar way, print sys dot get size of B. Okay, let me run this program. One is generator expression, second one is okay, give me a minute. X in range of, I'll take 1000. Okay, because generator expression is good for large data processing. Okay, otherwise you cannot able to get the output correctly. Okay, because this is for large data units. Now you can able to see how much memory it is taking for generator. Okay, so if you see here how much memory is taking for so for x in range of 1000. What is x in range of 1000? X in range of 1000 is nothing but 0 to 999, right? So 0 to 999 is nothing but range of 1000. So we have 1000 values. For 1000 values, what we are doing? We are doing cube of it. And here if you see generator expression, how much memory it has allocated? It has allocated only 128 bytes of memory. So 128 bytes of memory is sufficient to hold the generator object A, and it can hold all these 1000 values. Okay, so it is taken only 128 bytes of memory. For list comprehension, how much memory has been allocated here? If you see, it has allocated around 9000 plus bytes. So 9000 plus byte is very huge memory. So when it is huge memory, then obviously memory constraints will be there when you are implementing a real-time project. You cannot use large memory for all this kind of small data operations. So for small data operations you cannot have huge memory, right? So you have to bind your memory, you have to optimize your memory. So to optimize your memory, people use generator objects, and this is for large data processing. For small data processing, I don't think generator expression will help you out, because in the previous example, if you look at, I have taken only 3 values. For 3 values, so I don't think a generator object will help you out. Okay, you can go for direct. But when you have a values of say greater than 500 or bulk values, then obviously generator expression will help you out. You can able to see 128 bytes of memory is allocated for 1000 values when you use generator expression, and for 1000 values when you use list comprehension, it has allocated 9000 bytes, which is almost greater than 8000 some change, right? So 8000 bytes, which means almost 90% of data. Only 10% of data memory is been allocated here. 90% of memory is allocated. So you can quickly understand the main advantage of generator expression in the real-time scenarios, because in the real-time scenarios, obviously the memory should be efficient, and you can easily handle pipelining with the concept of generators, because it will be doing only one block at a time, right? So one at a time. So though you have 1000 values, you cannot heal all 1000 values at a time. So only one value will be yielded at one point of time. So that is also very important. And if you want to create an infinite sequence, for example, say If you want to create an infinite even numbers from 1 to so on, then obviously you can use generator, because you cannot say how much memory has to be allocated here. In the previous example, if you take, you have taken 1000 values, right? So if you have an infinite sequence, the optimization of memory is very very important. Then obviously people use generator concept in generating infinite sequences. Okay, so that's all. Hope you have understood the concept of generators in Python. Okay, if you have any kind of doubts, okay, regarding this concept, you can reach me on the Telegram group. So I have shared the QR code in the starting of the slides, so you can scan that QR code, you can join our Telegram group. And if you have still more to ask, you can also connect with me on LinkedIn. So this is my LinkedIn URL, you can search with my name, you'll get my profile. You can stay connected with me on LinkedIn. If you have any question related to this first episode, you can quickly ask me there, or you can ask me on Telegram group also. Okay, so that's all in episode 1. Will come you I'll be back with the second episode on day after tomorrow. At some time I'll just post it on my YouTube channel. If you like this topic, please hit like video and subscribe our YouTube channel. And we are coming up with different types of technical and non-technical stuff on our YouTube channel. We are coming up with different projects also. So maybe tomorrow I'll be coming live to talk about a project on machine learning or IoT. And also we have different types of live streamings which have been scheduled already. You can go through them. Okay, if you like the topics, please hit like and join me live during the streaming. Okay, so this video, if you have missed the live streaming, it will be added to the playlist. You can watch this video n number of times. Okay, if you have not understood the concept in a single sitting. Okay, though if you have not understood this, you can reach me on my LinkedIn, or you can send me a message on the Telegram group, and I am always help you out clearing all your questions. Okay, thank you, thanks for joining me in this episode 1. We'll meet you on day after tomorrow with the second episode. So like this, I will be scheduling 12 episodes in season 1. So I'll be talking about 12 different topics in Python, which are not basic, they are just bit advanced. Okay, so because I'll not be talking about the basic fundamentals of Python, I'll be talking about the intermediate and advanced topics in Python. You can always get those on my YouTube channel in the coming days in season 1. Okay, thank you all. Hope you all like this video, and any questions, you can reach me on Telegram group. Okay, please subscribe our YouTube channel, and we'll meet you soon.